Hello. Okay, it's time to start with our first speaker for today, Stanislav Toshev, the engineering director at Merkle, with impressive 20 years of experience in web development and expertise in various technology and platform. Stanislav will now share his insight on building a large-scale front-end architecture with reusable web components. Stanislav, the stage is yours.
All right. Welcome, everybody. First of all, I'd like to thank you for being here and choosing to listen to me. I hope you're going to enjoy that talk. I would like to thank to the organizers for making that possible, for all the sponsors, and I hope that you enjoy the conference today. Okay, the topic today is building a large-scale front-end architecture with web components, and cool. And a few words about myself. My name is Stanislav Toshev. I'm a director of engineering at Merkle, Sofia. I have over 20 years of experience in web development. I've seen many technologies, many platforms, many challenges, many good things in my career. I've taken various roles, mostly on the technical side, also management roles. And I've been part of Merkle since 2014. And Merkle gave me that t-shirt for free, so now I'm going to need to say a couple of words about it. So Merkle is a global company. What we do is data, commerce, and experience. We have offices all around the world, and in Sofia we are more than 300 people, many engineers, QA developers, business analysts, architects, project managers, and so on. So what we do is mostly commerce and experience. Okay, with all that, I'm going to move to the next slide. So today I'm going to speak about our experience, our journey with one of our big customers. We went through a major transformation from a technical perspective with them. So I'm going to tell you more about why we decided to choose a specific approach, namely using web components and component-based approach in architecture, how we did it, what were the problems that we faced during that journey, because there are always issues, and what we learned or what we rediscovered, because normally, sometimes you actually forgot things and then you figure out that you face the same problems again and again. And I'm going to share our experience. So we are probably not the best. It's not the best solution maybe. It worked well for us, but I'm going to share why we did it and what we thought when we took the decisions. So it's basically our experience. All right. So, in order for you to understand what we did, why we did it, I'm going to share some more about the background. So, first of all, the solution or the project we were working on was an e-commerce solution for a big international skincare retailer. The customer, we worked together with the customer very collaboratively. They have business and content teams. They have UX and design teams, so we work directly with them, which makes the setup quite challenging, I would say. It's a big project. We have over 36 countries, markets, so this means different size, different regions, different languages. We have right to left, we have top to down, and variations of writing. We have a lot of integrations, more than 120 integrations, so this makes the whole setup very complex. The team itself, it's more than 60 people, which consists of more than 20 developers, 20 QAs. We have architects, project managers, so you can imagine that it's a huge scale. So many people working together alongside with the business teams, the content team, and the UX team. This creates a complex environment. And it's a legacy customer. Proudly, we have been working with them for more than 10 years, but this also brings negatives because you can imagine as technical people, we created a lot of source code. All right, so with all that background, this leads us to the challenges that we faced and the challenges that we reached, so we had to resolve in order to move forward. Number one challenge was site speed. The site was very slow, and SEO people would say that content is king. King in e-commerce, speed is king. The faster your site is, the more you sell. So speed was a major concern. The technical architecture that we gathered in the years, that accumulated the debt that we have, that we had, is something that also brings complexity. Complexity scale. Imagine 60 people working together on the same code base, releasing over time. We have 36 markets. All markets, different markets have variations, so there are different payment methods, different functionalities, different UX even at certain points. So this brings further complexity. That complexity leads to another problem, of course. There are more dependencies between teams. If you make a change, you probably break something else. Or if you make a change, you need to figure out how this influences or how this impacts other people in the team. If the design team comes up with fancy design, this might not be very easy to implement, and this might bring another complexity. For example, we have a design that is already used, but then they bring something different, so we need to figure out how to create that, how to make a variation, and how to avoid technical debt, which might not be possible. A lot of customized features, a lot of customized components, features would not be the same across different sites, different markets, so that was a challenge. The way we work with the customer, couple of business teams, couple of content UX teams, they didn't work very well. We didn't have a framework, let's say, a process that would combine all that into a mainstream way. So every team would take their decisions. They would not collaborate very well. So the design team could come up with a very fancy design, but then the business team would not be happy with that. Then no one would ask the technical team if this is feasible or not. So that was a big pain, actually. And again, it's not about technology, it's more about how we work together, and missing a framework or, let's say, a streamlined process to achieve, let's say, effective work together. On top of that, we, as a team, we use a platform, e-commerce platform, that we built our solution on top. It's called Salesforce Commerce Cloud. So basically, the platform itself has certain limitations that let's say, don't make it easy to use cutting edge or something that is very popular, meaningful for us. So we need to also think about that. Okay, so we had time with the customer. We discussed those challenges. We, of course, came up with goals that we wanted to achieve. So we realized that we need to make a big technology. Sorry. We realized that we need to make a big technology step. So we defined our goals. Basically, we separated them into several categories. Performance, number one priority, I would say. Our site was not fast, unfortunately, and we wanted to be number one with speed. We wanted to load efficiently resources, so basically load whatever we want and only load things that we show to the customer. We wanted to clean up third-party libraries because we had a lot. Imagine a lot of regions, a lot of specifics on the regions, different third parties, both on front and back-end side. And we want to benefit from mobile-first approach and, let's say, mobile-ready application. From engineering point of view, what we wanted to do, we had a big team, obviously. We still have that big team, and we want to deliver faster. It became, let's say, unacceptable to spend 5 days for a very simple change. We wanted to onboard people more quickly because it took a lot of time for new joiners to get onboarded, to start working effectively. And this is the issue. When the customer pays, when they expect certain delivery, you need to figure out how to do that in a smart way. We want to adopt the latest Salesforce tech stack innovations. We want to adopt the latest front-end design tools that were out there, and we want to make it very easy to be AA compliant in terms of accessibility. One of our websites is in the States. You know that in Europe it's something that will come very, very shortly, basically. So we want to make it very easy to support that. We wanted to Another big pillar would be quality. So we wanted to introduce more unit testing so that we could more effectively, easily create unit tests, have bigger coverage from automation perspective. We wanted to clean up our code. You know, as engineers, everyone loves refactoring, so we wanted to refactor. And we wanted to be able to test on an isolated manner, so test the component, not the whole page. And from business point of view, although technology is very important, you always need to think about how you solve business problems. If you pick up the latest and coolest technology, it might not solve business problems, so then you're not successful, although you might enjoy it as an engineer or whoever's working on that project. So we wanted to create a very simplified process with all customers' teams so that no changes, no deviations happen. We handle that very in an effective way. We want to deliver all that in iteration so that we deliver as quick as possible. We didn't want to spend, let's say, 1 year refactoring, replatforming everything and then release it with 1 year. We wanted to do it right away as soon as things go. And we, of course, want to increase the revenue. So after all, the purpose of every business is to sell more. All right. Then, of course, we started thinking about what we need to do in terms of architecture, how we achieve those goals. So we, of course, considered various options. We take into consideration various limitations. But at the end, we came up with the solution and decision that we need to use a component-based architecture. And the reasons to go for that was that besides the obvious design benefits that we all know, solid, dry, and so on, there are things related to how we very easy introduce changes, how we maintain in a very simplistic and effective way. We introduce more unit testing, as we said, so we don't use the whole page. We test or we center our focus on components, basically, so we could work in isolation. We could use it as building blocks, and we want to decouple the front end and back end as much as possible. We all know, or maybe most of us know, the benefits of that. And of course, from business perspective, we wanted to be fast. I already said that, but that's very important, especially in e-commerce. Not even e-commerce, you must be fast if you want to be top. We want to be accessible, as I said. We wanted to find a way to, load and use web resources in a very smart way. We wanted to make the solution or the components or the pieces in that solution available by third parties, because some third parties use whatever you have as a website, and for example, some of them might not work with React if you go with React or something else. So we wanted to make it very easy, and we want to make native support for those. We wanted to create, of course, a library of components so that the business could go, see what's in there, and take decisions on new functionalities based on the existing component based. The design team would not go and, let's say, create very fancy stuff that you could not easily implement. So we wanted to, of course, put that into the component library. It's something that is common with all, I would say, all component-based libraries out there. And we wanted to make it very easy to make changes on the website that would be reflected in many areas. So basically, we want to update a single component, and then the change to be updated, reflected everywhere without the hassle of regression. So that brings us to the components themselves. A few generic sentences here. How we work and how we design with components. Probably most of you are familiar with components. Some of them use React, other people use Vue, and so on. But components are basically, you could think about them as Lego blocks. So basically, every web page is built from a number of components. Components could be a simple input field. It could be a button. It could be an image on the site. It could be a more complex stuff. So basically, you take those components and you put them together into a nice Lego piece or a web page. Our approach as an architecture is based on atomic design. Another concept, I'm not gonna go into it deeper, but basically we use that approach for both backend and frontend. That's very important because it will then later give you idea why we chose web components at the first place. And this is pretty much in a nutshell. Okay. Few words about the architecture. It's quite simplified, so it's not really, it's not very, I would say, accurate in that sense. But we have our e-commerce platform on the bottom. It's Salesforce Commerce Cloud. It has limitations. I need to say that in terms of architecture, in terms of how content is delivered, in terms of what you could do in terms of client-server, let's say, interaction. Then we based our backend components on top of it. Backend is based on JavaScript, so server-side JavaScript, similar to Node.js, but another JavaScript engine. Basically, we have backend components for all those components you could think on the front end. So a product image, a product tile, or this is simple, small product component on your search page is a component. Then an input field is a component. So we have our backend components. So the logic is in the backend is really divided into components there. So we're not using the typical, let's say, MVC pattern here. We don't use any service-based architecture here. It's basically we use components built on top of that platform. Then we have front-end components. This is not fairly accurate because you can have a single backend component that could use multiple front-end components. So we need more arrows here and here. And on top of that, a backend component could be built out of more backend components. So it could be a compound component. Then with all the markets that I mentioned, we need to have, and we have market-specific components. We consider that piece here as a core. So basically all the websites would use that. But sometimes you have deviations for different markets. For example, Asia. And then we create market-specific components that are separated basically. But again, it's the backend component who could use the core component. And this could be extended for a specific market with a market-specific front-end component. Okay. In order to understand better, I need to give you more details, but I don't want to go there because I'm going to lose you probably. With all that in mind, just an example of how we compose a specific component. It's nothing complex. You've seen that, I guess, especially people who work with that. But basically, we have one page, which is, let's say, a search page. For the matter of this talk, it's quite simplified. We're missing search fields and things, but please ignore that. So we have a header, a footer, standard elements, and we have a number of product tiles. A product tile is basically image, price, title of the product, so something that shows on the search page results. And each of those components are basically, as we said, they consist of their encapsulated JavaScript, CSS, and HTML. And they come with their backend component in most of the case. So in order to create that page, we have a couple of backend components here that are combined by the page layout. Each of those components, they use and render their front-end components. Some of them could render more components, some of them would render a single one. And all the logic of the different components will stay encapsulated into the component. So basically the backend component would know and would only care about the logic related to that component. The front-end component, of course, would only care about rendering that component, of handling front-end logic. So it all stays there. That's very important. It might not be very interesting, or it might be common sense for you, but I'll explain you why this is very important in our case. All right. So we decided it's a component-based approach that would help us achieve our goals, And then we had to decide what components we're going to use on the front end. From back end, we were kind of limited. The platform was there. One potential solution was that we scrap the back end, but you can imagine 36 websites, millions of orders. That's not an easy task, and you could not go and convince the business that they need to scrap that solution you built. You built something new, fancy, but it will cost them 2 years of effort of a team of 60 people. So backend was kind of limited, so we had to deal with it. And on the front-end side, we had to consider several things. Backend obviously in place, the technology constraints that platform gave us. What was the client ecosystem, the client ways of working, their teams? I already mentioned about their design teams, their UX teams, so we had to take that into consideration as well. What we also considered was what third parties we used. We have a lot of third parties, not only backend integration, but also many front-end integration, reviews, ratings, A/B testing, and things like this. And we had to take that into consideration. Some of them are very, very deeply integrated into the solution, so you could not come up with a solution that would break all the third-party integrations. Or we need to measure out. Basically, you need to figure out if you go with a architecture or technology that is not supported by those third parties, you need to calculate what would be the impact of rewriting all those if possible. So we had to consider that as well. And of course, we did an evaluation of all, let's say, meaningful, all the platforms, all the technologies out there at the time we took that decision. So we evaluated many of them. We shortlisted to 3 web components, which I'm going to speak about in a moment. React and Vue. So after, of course, thorough and due diligence we decided to go with web components. And I'm going to tell you why we decided. So from our perspective at this time, so this happens some time ago, it's not something that happens yesterday because it's a large scale, so we had to spend time to do that. So on the positive side, we realized that web components are faster. They're native, so there is no corresponding library like, for example, React, you have 50 or 100K that you need to load additional logic. So they're natively supported by browser, so very minimal footprint. That was very important for us, especially when we wanted to be very fast as a website. They can be used directly with any libraries that could manipulate DOM APIs, because they're part of DOM, they're natively supported by browsers. They're not related or bound to any framework, which is a positive thing, but also negative thing, and I will tell you more about that in a moment. The learning curve, we believed, was very, very small, because it's basically vanilla JavaScript, knowing DOM and how the browsers work. It should be fairly straightforward. Of course, it was not the obvious choice, it was not the easy choice, because there was also some drawbacks. Some of them being around the ecosystem was smaller, so if you want to build something and use React, you have a big community, big ecosystem, so you could take a React library, just plug it in, it's up and running. With web components, the ecosystem was not that big, so we had to take that into consideration. Single page application is not natively supported, was not natively supported, so we had to do it ourselves. It was not very well known at that time. Maybe it's not very well known as this time too. And we had to take that into consideration as well, because people are attracted to trendy technologies, to popular mainstream technologies, and this could have been a challenge. And we'll see if it was basically the way components would communicate. Web components was not decided, so it was not in the way like React, for example, does it with router and things. So we had to figure out the way components need to communicate with each other. So there is no prescription. So basically we had to take that into consideration as well. So just a couple of words about what web components are, after all, because I'm talking about that, but I guess some of you are not aware. I'm not gonna give you deep examples. It's just on a high level. You could open internet, you could write web components, look for that logo here. So web component is a web standard. So basically it's natively supported by browsers. It's the analog of component-based libraries like React. So it allows you, the browser allows you, it provides a set of APIs to create custom HTML tags. It allows you to encapsulate all the related CSS, JavaScript into a single component. And that's natively supported. Of course, those APIs are being developed with time, but this is really in a nutshell. And I'm gonna move now to, this is not working. So I'm gonna move now to how we did it. Again, I'm not gonna give you many details, so please find me or at the end, or find me after the presentation if you're more interested. I could give you more details as much as I can. I can see some colleagues here who probably know better than myself, but I'll try to answer or guide you to them. But in a, let's say, high level, from technical perspective, what we did was we reworked all the backend logic. So one of the, as we said, considerations we had was existing system, existing platform. So all the source code was there. So it was, let's say, kind of effective that we took it, we refactored that. So we reworked all the backend logic to make it component based. We did all the front-end development. Obviously, we had to create all the web components from scratch. We did test all the components in isolation. This is for the components themselves, and for every and each component we had to document that documentation we added to the component library, we added to the respective API documentation. So this is what we did, and then furthermore, of course, this is on the component individual piece, but for every page we had to, of course, build the page template itself to take all the components we created on the previous step. So we created the pages. We had to test, of course, with all the non-functional requirements and testing we do, visual testing, automation on that, end-to-end, and so on. Apply tagging and basically document. And we, of course, released that as it went. So basically, whenever a page was developed, we would release it. And that was a challenge, and I'm going to tell you why. On the component side, again, once we had a component that could be reused on some of the pages, even not, let's say, migrated to the new architecture, we released that. It was a heavy process. All right, and because it's an IT conference, there are developers, there are QAs, I could not help but show a single slide with some source code. So this is a web component in our world. Of course, it's enhanced. We have, let's say, good and nice hierarchy of classes, basically. But just to illustrate that, this is a component that creates the product tile. This is the front-end part, the web component. So there are a couple of lifecycle methods here, but if you're interested, you go and read about web components. We do some actions. It's not the full screen, but then we render. If you go below the fold, but this is how it looks like. It's vanilla JavaScript, ES6, so it's generally nice. And this is the result. So basically, it's quite easy to create that. You take the backend component, you create it, of course, the first time, but you take the backend component. If you need to plug the product tiles on a specific page, you just instantiate your backend component. You take the front-end components that you need, you feed them with the data, and they render. Quite easy, I would say, to do it once it's done by someone before you. Okay, so far so good. That was all very nice, I guess, interesting, but there were challenges. And if someone tells you that they deliver something big, complex, and it was very easy, don't believe them. So there are different challenges. Ooh, how did it get? So with web components, as I said, we didn't know how to make components communicate to each other, so we had to figure that ourselves. We didn't know how to actually use state management. There is no state management by default, let's say, with web components, so we had to figure out that ourselves during the road. We needed to make Webpack only load and deliver the resources that we wanted. And we also wanted to render and deliver to the browser only the pieces that you need. So those are big challenges to us, I would say. A bigger challenge, however, was the mindset change, because you have a team of professionals, IT people, who need to start thinking about abstraction and component-based approach. So it's not that easy to do that mind shift. And also from customer perspective, it was the same challenge, I would say. Another challenge was that we had to change our approach a few times. One of the biggest changes was we started doing the communication between components, but then it didn't work well, so we had to introduce state management. Web components don't have state management, but by default, we luckily find out a simple library that worked out for us, but we had to introduce that midway, which was another challenge. And for business point of view, don't kill me. At that time, it wasn't that long ago, but there was requirements that we support Internet Explorer 9, which is a nightmare, you could imagine. We had delivery constraints. We had to be fast because we couldn't spend much time on developing that. We need to bring value to the customer, so we had to be very smart, effective, and at the end deliver something meaningful and not scrap that we want to refactor in 2 months' time. The other, maybe the biggest challenge is how we do the transformation page by page, because you can imagine it's not something that happens in 2 weeks. So you create a bunch of components, then you create a page, for example, product details page, and then you roll out that. But then the rest of the website is still using the old architecture. So the challenge is how we actually put together the new component-based architecture, the old component-based architecture, put them on different pages. Sometimes we even put components on old pages and keep the site, let's say, live, so we don't degrade performance too much and we don't kill ourselves. So that was the other big challenge. And of course, customer team transformation, it was a big change for them, where we need to, let's say, limit the design team. When they need to create the design, they need to work with the components, but it was for good after all. And what was the results? So basically, we are happy with the results. I don't have, let's say, summary with numbers. This is on purpose. I'm not here to show off, but we improved the site speed dramatically. We achieved better code, maintainable, readable, and so on. We followed industry code standards, so that was a big thing for the team. We made it very easy to build a new page and to make changes, to introduce changes to a page. We introduced tools like Figma, and it was very easy for the design team to work with that, the business team to work with that, the architects to work with that. It's not, rocket science. I guess some of or most of you use that, but still, we improved the site footprint, and obviously we improved the site of the design of the website because we had to. So just a couple of notes. An example. This is some KPIs that we measured before we started on a specific page, product details page. These are some KPIs that we achieved afterwards. I'm not saying if those are best, but I'm saying that it was a dramatic improvement in page speed. We again minimized the footprint. Again, don't kill me. Those 13 megabytes, it's not because we put a lot of resources. There are many third-party libraries, so we need to take that into consideration. But after the replatforming, we reduced 3 megabytes of resources because we scrapped many third-party libraries. We scrapped some libraries that we already used. So basically, it was a big gain for us. And now maybe the interesting part, what we learned. Okay, If you don't use a mainstream technology, then you need to be ready to support it. So you won't find answers, most of the answers in Stack Overflow. You won't have the community, and you won't be able to find the library that solves your problem. So we need to figure it out yourself, and basically you need to contribute to that. That's something that we need to understand and accept. So, learning curve for new people in the project. We have projects with React, for example. So if you, let's say, as a company, do web development and do something similar, and you have one team that uses React, another team that don't use React, and you switch people, there is a learning curve. That's something that you need to consider. So if you need to move people around projects, you need to consider that. If, let's say, our architectural solution was React, then it could be easier to or faster to onboard people because they'll just switch, use React. But you need to consider that, and it's a big team. We considered it. All right, so we spent much time and efforts to get it right. So we made a lot of changes in the initial phase, so it took us a lot of time and efforts until we get it right and do the setup the way we wanted and the way we could because of all the limitations I mentioned. But then it paid off because it's very easy for new people to join in and to onboard on that project. They start using that very effectively, so just build up some components, put it, and they work. The question, if they understand how it happens, it's another topic, but not for now. A general advice, I've seen that with other projects again, but spend time. Don't underestimate the time for preparation. Spend time to really think about all the complications, how components would work, how the page would load, what the performance would be, what third-party libraries out there would be, and things like this. Spend time and think about the overall architecture. Don't underestimate that time because it's important. Then if you don't have the right, or let's say close to right setup in the beginning, then many people would struggle. So basically spend that time beforehand. And if, let's say, the business or the company say you don't have that time, insist that you have that time. It's very important. Then whatever you take as a decision, be ready for changes. And what you initially thought might not be what actually you end up with. So be ready to make changes and live with that. It's not a big deal. I mean, part of our life, so just accept it that it's possible and it's not your fault. It's just how life of IT people is. There will be always challenges, what I said before, no matter how good you are, how well you know the technology, especially in complex environments, there are challenges. There will be challenges, accept that as well. And again, it's not that you didn't think it very well, you didn't do the right thing, it's that this life. Okay, I already mentioned that, but it's very hard to handle two coexisting technologies at the same time. We did it, but we struggled. So think about that as well. How you roll out the new technology, especially if it's an existing project, because if it's a new project, it's easy. You just go, do it for scratch, and it's roses, as they say. Okay, that's another piece. You need to think about how attractive this could be for new people. Some of our colleagues actually weren't very attracted to joining that project because it was not React. I would say it literally. And you need to think about that. How easy is to find the right talent? Because some people, they're attracted to cutting edge, to trends and so on, but also there is this aspect that you need to do the right thing, which brings us there. What is surprising to me personally is that actually many people enjoyed using vanilla JavaScript, and they enjoyed it more than we thought. So they overcome that first, why not React? Let's say prejudice, and they now enjoy it. Now it's hard to take a person out of that project and put it into a React project, believe it or not. Okay, handling variation is not an easy task, and maybe one of the important pieces. You need to make the right decision. So you need to take the right decision for the team, the right decision for the project, for the customer. And you should not be influenced by what is popular out there, what you know. Don't let that as let's say decision point. Of course, if you have the team of people capable of a specific technology, and you think that upskilling to another technology will take more than using the existing technology but not providing the best solution, that's okay. But consider everything and take the right decision. Don't be afraid to use something that is not popular out there. Of course, have all what I said so far, have that in mind, but be brave and do the right thing, just on the side. And sometimes you might realize that not all goals you actually set are achievable. So we achieved, let's say, 95% of the goals. Some of them we didn't, but that's life again, and the result was good. And I kind of wait a couple of minutes for questions, but now's the time for questions. If you don't feel comfortable, I'll be around, so please stop me by, ask me questions. But of course, now you have the time to ask some questions. Thank you for joining and enjoy your conference.